Sick. All right, from the 403 to the HAZ. I am milking this last day before spring break for as many videos as I can because I have Michael writing a quiz, Mariah doing nothing as always, and Caitlin's just taking a little nap on my desk. That's how many students I have. It's chill. It's all good. It's all good, baby. It's all good. So we're talking about rational expressions. We've talked about simplifying them, and it requires a lot of factoring. We talked about non-permissible values. We've done multiplication. We've done division. And now we're adding and subtracting. And adding and subtracting rational expressions is just like adding and subtracting fractions. Okay? Because when I'm doing this, when I'm adding and subtracting fractions, I need to work with a common denominator, sometimes we call it the lowest common denominator. But the common denominator is good enough. It doesn't have to be the lowest one because we can always simplify. But that is basically, in this case, it's going to be b times d, right? And I know that I have to multiply a over b by d over d to get that with the same base. And over here, I have to multiply it by b over b to get the common denominator. And when I were to do that, I would get AD over BD plus CB over BD is equal to, and now we keep the common denominator here and we just add the numerator. It would be AD plus CB, okay? That's just using random, you can just assume A, B, C, and D are just numbers, okay? But I'm just showing you that our common denominator we determine simply by multiplying the denominators together, okay? Unless I have A over B plus C over B. In this case, they have the same denominator, so I can just go straight to adding A plus C. And we're going to see both situations with our rational expressions. I'm going to check if I'm still filming because I've had bad luck recently. Still filming, look at that. So, let's say I have, Michael's writing a quiz on this stuff right now, so I'm actually helping him out, that's cool. You know what, sometimes you just hit the lotto in life. Sometimes things just push up Millhouse, you know? You know. So let's start really easy. Let's say I have 3x over x plus 2 minus x minus 2 over x plus 2. Okay? In this case, I notice that I have x plus 2 as my denominator in both expressions. You just use me for my sleepy time. Okay, so I can go ahead and use that x plus 2 as my common denominator. I don't need to multiply them because they're the same. They are the common denominator. And I'll show you another case right away here after this. So now I'm just going to do what it tells me to do up there. I got 3x, and I'm going to subtract minus x minus negative 2, so I can add that. And then I'm going to simplify. 3x minus x is 2x plus 2 over x plus 2. And then if I wanted to, I could simplify this further to 2x plus 1 over x plus 2. And then I can do my non-permissible value where x cannot equal negative 2. It can't be, because negative 2 will make it 0. Okay? Now what if I had 3x over x plus 2 minus x minus 2 over x plus 2 squared? In this case, I would have to multiply x plus 2 over here by another x plus 2 to get this. So x plus 2 squared in this case is our lowest common denominator, which I can rewrite as x plus 2 times x plus 2. So to be on the same common denominator, this guy I'm going to have to multiply by x plus 2. So I'm going to break it down over here. I've really been dreading making these videos because I feel like sometimes I get discombobulated. There's a lot to go over here. So this fraction's already over top of the lowest common denominator of x plus 2 times x plus 2. But 3x over x plus 2, if I wanted to convert that fraction into a fraction over x plus 2 times x plus 2, well, to get from x plus 2 to x plus 2 times x plus 2, I had to multiply by x plus 2. So whatever I do to the bottom, I have to do to the top. So I'm going to multiply this by x plus 2, just like with regular fractions. So I'm going to get 3x times x plus 2 over here. Okay? So now this fraction becomes this, and this guy stays the same. So I can rewrite this as 3x x plus 2 over x plus 2 squared, x plus 2 squared, there's two of them, minus x minus 2 over x plus 2 squared. Okay? They have the same denominator now, so I can actually just go ahead and put it all over that one denominator, x plus 2 squared. And I'm going to actually expand this, because I'm going to try and, because I have to subtract that, so I'm going to expand and then simplify. So there is a part where we're going to expand here. So I'm going to expand it by multiplying. 3x times x is 3x squared. 3x times 2 is plus 6x. And then I'm going to subtract x, subtract, so add 2. Minus minus is plus. I have 6x minus x there, so I can rewrite this as 3x squared plus 5x plus 2. I'm just trying to figure out if I can actually factor this using decomposition nicely. 6, two numbers that multiply to 6, add to 5. I can probably do it. I don't want to, but I'm going to. Anyway, so that would be over x plus 2 squared. Okay, and my non-permissible values are that x cannot equal negative 2. Negative 2 will make that 0. That's it. Now let's finish factoring that. She's in the house, ladies and gentlemen. Okay, 3 times 2, this is decomposition, makes 6. And I want two numbers that multiply to 6 and add to that 5 there. And that's going to be clearly 3 and 2. So I'm going to replace the 5 with 3 and 2. So I'm going to write 3x squared plus 3x plus 2x plus 2. It doesn't matter what order you put the 3x and the 2x, but usually there's one way that's going to make common factoring a lot easier, and that's this way. And so I'm going to pull out a 3x, x plus 1. Whatever's in there is going to be in here, x plus 1. Now what times x plus 1 gives us plus 2 plus 2 is 2, plus 2. So I have a common x plus 1 across these two. So I'm actually going to factor out that x plus 1, and I have to multiply it by 3x plus 2. And that's going to be my factor. So I can rewrite my answer here as, and I have to do that because there might, once I add or subtract, when I factor it, I might actually get something that will cancel with the denominator. But in this case, that did not happen. Over x plus 2 squared, where x cannot equal negative 2. So here's a situation when I'm basically, I either already have a common denominator, right, the same denominator, or I have a denominator that's the square or the cubed of this one. If this was cubed, I'd have to multiply this guy by x plus 2 squared to get x plus 2 cubed. That's that situation. So let's do another example now. Increase complexity ever so slightly. Okay, so let's say I had something, it's not so bad, not so bad. Even Mariah could do this one. I'm just going to come up with it. So I've got 2x over x plus 3 plus 3 over x minus 1. Okay? That's it. So my common denominator here is just going to be this times this. So my common denominator is x plus 3, x minus 1. And I can actually, in this situation, I can cross multiply, right? That's essentially what I'm going to do and get the common denominator. But let's go through it the proper way. So I've got to get 2x over x plus 3 into the common denominator, which is x plus 3, x minus 1. So I'd have to multiply that by x minus 1 to get here. So whatever I do to the denominator, I do to the numerator. So I'm going to get 2x times x minus 1 over here. And as you can see, that's just the cross multiplication there. And then, this guy I have to do the same thing. So I've got 3 over x minus 1 is equal to x plus 3, x minus 1. I have to multiply x minus 1 by x plus 3 to get there. So I have to do the same thing to the top. X plus 3, and I get 3 x plus 3, which is exactly what would happen if we just cross multiplied. So now, I can rewrite this as 2x, x minus 1 over x minus 1, x plus 3, plus 3 x plus 3 over x minus 1, x plus 3. And this blue is failing. And now I can, I'm going to expand this. So that becomes 2x squared minus 2x plus 3x plus 9. And that's going to be all over my common denominator. Okay? So I just expanded the multiplications and added them all together because they have the common denominator. Now I'm going to collect terms, and I'm going to notice that I get 2x squared plus x plus 9 over x minus 1, x plus 3. I'm trying to figure out if I could do decomposition here. 2 times 9 is 18 and adds to 1. Are there any two numbers that multiply to 18? 6 times 3 is 18. That's not going to work. 18 divided by 4, no. 18 divided by 5, divided by 6, 7, 9. No, so I can't solve this one with decomposition. I'd have to solve the top here if I wanted to factor it using the quadratic formula, and that's going to do nothing for us. So I'm going to leave it in that form, and there's nothing I can cancel. Therefore, my non-permissible values are in the denominator, and I do them at the end here, and it's 1 and negative 3. Yeah, that's the answer. That's adding and subtracting rational expressions. Now let's try and find a somewhat difficult one here. Okay. 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 Okay, I'm gonna do this one. Okay, so I've got 5 over y plus 1 minus 1 over y. This is going to be a 3-term subtraction. Y minus 4 over y squared plus 1. Okay, so the first step, as with everything that we do in rational expressions, is to factor anything that we can factor. And we start factoring with our common factors, and then we move into trinomials if we can. Everything is factored here except for that guy. So if I factored that guy, I could rewrite this expression as y 5, and then I can pull out the y, and it becomes a y plus 1. Okay? So, my lowest common denominator here is y times y plus 1. Because if I multiply this by y plus y, I'm going to get that denominator. If I multiply that by y plus 1, I'm going to get that common denominator. So my common denominator, my LCD I'll call it, even though it's not necessarily the lowest, is y times y plus 1. Just as if I had 5 over x plus 10 over x squared minus 15 over x cubed, my lowest common denominator here would be x cubed, and then I'd multiply the top and bottom here by x squared over x squared. I'd multiply this guy by x, and then I'd leave this guy alone. And then I'd have a common denominator across all three that way. Okay? So here, we're kind of the same idea. So I have to multiply 5 and y plus 1 by y to get that common denominator. So 5y over y plus 1. I have to multiply y by y plus 1, so whatever I do to the bottom, I have to do to the top, minus y plus 1 over y plus 1, minus y minus 4, y plus 1. This guy gets to stay the same because he's already got that common denominator. Now, I'm going to write it as one long thing. So I've got 5y minus y minus 1 minus y minus plus 4 all over y plus 1. And I'm going to collect terms. I've got 5 minus 1 minus 1. 5y minus 1y minus 1y, so that's going to give me 3y. And then minus 1 plus 4 is plus 3 over y plus 1. Now I'm going to factor the top there, because when I do that, something's going to pop out. Y plus 1 over y plus 1. Now remember, I always do my non-permissible values before I start canceling. So my non-permissible values are going to be y cannot equal 0 or negative 1. But I can't cancel those. So my final answer is 3 divided by y, where y cannot equal 0 or negative 1. Okay? So the steps here are, you want to factor everything first when you're starting. And you use common factors or trinomial factor, and then trinomial if you can, trinomial factoring. And then you're going to find the common denominator and make all your expressions equivalent to that being over that common denominator. You do the equivalent fractions, convert all of your expressions into expressions with the same denominator. And then you are going to add or subtract. And you're also going to expand your numerator, expand all the multiplications. So while expanding. Expanding just means if I have, like if I have 3x plus 2, expanding just means that I'm going to actually do 3 times x, so it becomes 3x plus 6. We need to do that in this case so that we can add and subtract properly. So we got to expand. Add and subtract and expand. And then once we've done all that, once we add, subtract while expanding, we're going to simplify the numerator. And by collecting the same terms, and then we're going to factor if possible. there are quite a few steps here. There's a little more nuance to adding and subtracting. And finally, NPVs, and then we can cancel terms that show up in the numerator and the denominator, if there are any. Okay, those are the steps-ish. I did that for Michael. I did it for you, buddy. So that's all I think I need to talk about here. These skills are going to help us when we start solving rational expressions, which is the next video.